All right, there you go. So I posted an announcement yesterday, but I just wanted to kind of point out. So I updated the syllabus so that it has the GATA office hours, times, and locations on there. It's in Wiley. I also need to update this announcement after class. I realized I left off the location of these extra tutoring sessions. So I've got the times up here. They're all going to be in Wiley up on the 3rd floor. I'll update the announcement so that it has the exact room number. Now, they don't start till next week, so it's Tuesday, Wednesday, Thursday. But these extra tutoring sessions, those won't start till next week. They're not specific to this course section. It's like graduate students who are just going to be there who can answer questions that you might have. So just trying to provide you with as many additional resources. You know, I had a lot of people stop by my office yesterday. So you've got my office hours, TA's office hours. You've got these extra tutoring sessions. You also have what starts tonight, CL sessions. So there's some confusion from people. 2 things, and I've been trying. I know I've said this, so if you're getting sick of me here, but some people are still not clear. I know I put that list out there, but whatever CL daytime you're assigned to, do you have to go to that one? You can go to whichever one works for you week to week. You can change. Got a couple people email me, can you switch me on the list? I can switch you, but ultimately you can just go to the other session. It doesn't matter. Okay. It's really a way, to be honest, a way for me to cover my end on if someone wanted to make a great appeal about it not being available to them, which you guys hopefully no one would do, right? Also, when I say week to week, I probably should have clarified this. Our weeks start when? Weeks start new modules on Tuesdays. So our weeks go from Tuesday to the end of the day Monday. So there was no Monday CL session on Labor Day, right? The CL sessions start today, Thursday, and then that will be module 2. And then Mondays, well, when's the quiz due? The end of the day, Monday. So it's still covering module 2. So Thursday, Monday will always be the same kind of week or the same module. So this first week will be today's CL session and Monday's upcoming Monday CL session. Does that make sense? Okay. Okay. Other than that, is there anything else I wanted to mention? There was, now I'm blanking on what it was. Oh, I made changes to the grade book. So just kind of weight thing, the categories according, I'm going to make the changes so everything's weighted according to what it is. Now, early on in the class, like you shouldn't really be as heavily super focused on your grade, because ultimately once we start having the exams, those are going to be a significant portion of your grade, and the weighting can kind of change it quite a bit. But I do want to kind of have it match with the syllabus once we start having enough assignments from every category that I can actually have a grade in each category for them. You'll also see that if anything's ever late, right, late scores are always zeros. So it might kind of show, you know, it should start showing up to you now. If you had something late, you'll see a 0 there in the grade book. So when will the module 2 quiz be posted? As soon as class is over. What will also be posted after class today? Module 3 reading. Those are both going to be due at the end of the day Monday, with the module reading being due not quite at 11:59, but at 11:50, giving it time to sync and buffer. Okay. All right. Any other questions before we dive into material here? Okay. All right. So we left off with the gains from trade example. So I won't kind of revisit the entirety of where these came from, but I had enough questions and wanted to clarify a few things about these gains from trade examples. So I'm going to do a slightly different kind of set of numbers than the one that we used on Tuesday's class. But we started out, we had something that looked like this. So we had a matrix, or if we were given the information that using all of their resources, the U.S. could produce 30 aircraft parts, or if it was using all of its resources, 60 iPhones. India, we had 10 and 50. We then drew out their individual production possibilities curves, and we found the cost to one more aircraft part for each country which was 2 iPhones for the US, and then India, their cost was 5, right? That was the slope of their individual production possibilities curves. Now, if we were thinking about if they were doing without trade, right? Let's say I had the US and they wanted to produce just a hypothetical value. They wanted to produce 22.5 aircraft parts, okay? Well, they had enough resources to produce 30, so how many more aircraft parts could they produce? 30 minus 22.5 is 7.5. How many iPhones could they now produce with those 7.5 aircraft part resources? Well, if each aircraft part was 2 iPhones, if I take 7.5, I multiply it by 2. Each aircraft part is worth 2 iPhones. So I would have 15 iPhones. That would be a point that's on the US's production possibilities frontier, right? So the point would be what? 22.5 and 15, okay? There we go. Now, for India, let's say they also wanted, well, I can make this one of these a little bit easier. So they do what? 5 aircraft parts? If they could be producing 10, by not producing those additional 5, how many iPhones can they produce? Well, each aircraft part to them is worth 5 iPhones, so they would have 25 iPhones, right? All we're doing here is finding different points. So this was the US, this was India's production possibilities frontier, right? And we did all of this last class, right? So we just found this point was what? 5 and 25, okay? So this is before trade, okay? Any questions over anything here? Like I said, this is kind of where we left off. I went through a trade example, but I want to kind of point a few things out that maybe I wasn't as explicit about. So after trade, right, what we're going to do with trade is say, okay, look, whatever the 2 countries' costs are, we know that if the US, if it's going to cost them 2 iPhones to get an aircraft part, they'd be willing to accept anything, excuse me, if every aircraft part to them is going to cost them 2 iPhones, when they trade away an aircraft part, if they made it, or if they traded it away to themselves, they're only going to get 2 iPhones. So they'll trade it to anybody else if they're going to get anything more than 2. And India says, well, look, if we wanted to produce the aircraft part on our own, it would cost us 5 iPhones. We'll trade it away for anything less than 5. That would be better off for us. So we said our terms of trade is always going to be in between the 2 countries' costs. Okay, so in between 2 and 5. So I'm just going to say, let's say hypothetically, these 2 countries agree, we're going to trade 1 aircraft part for 3 iPhones. That's kind of our terms of trade. Also, because we're trading, we're each going to only produce what we have a comparative advantage in. So who's going to be producing aircraft parts? Who has a lower cost? The US. So we're going to have the US producing only aircraft parts. Who's going to have if the US has comparative advantage in aircraft parts, who automatically has a comparative advantage in the other good? The other country. So India is going to only be producing iPhones, producing the total amount they could, which was 50. Okay? So now when we let them trade, this is where we're using a hypothetical value. I could use 2.5, 4, 4.5. Any value in this range I could use to prove to you that the countries will be better off with trade. Okay? So if I think about the US, so let's say they want 15 iPhones. Okay. Well, they're not producing any right now, right? They were going to rely on trade to get that. So if I want 15 iPhones, how many aircraft parts am I going to have to give up? Well, if each aircraft part is worth 3 iPhones and I want 15 iPhones, I'm going to have to give up what? 15 over 3, right? Each one is worth 3. So I'd have 5 aircraft parts is what I'm giving up. So I'd be going from 30 to 25 aircraft parts. Right? So notice for the US, I've got the same number of iPhones after trade, but more aircraft parts. I can actually get to a point where I've got the same number of iPhones, more aircraft parts. I'm at a point on my production possibilities curve, which we said last class would have been what? On my own, it was unattainable, right? Same kind of idea. For India, if the US was giving them 5 aircraft parts, and each one was costing them 3 iPhones, right? They were going to have to give up 3 iPhones to the US get it. How many total iPhones did they have to give up? 5 times 3. So they started producing 50 iPhones. They're losing 15. How many do they have left? 35. So they've got, after trade, the same number of aircraft parts, but more iPhones. They're actually at a point that's up here. Both countries after trade end up at 2 points that were unattainable if they were trying to get to those points on their own. Well, there's never going to be an optimal point for trade as long as that terms of trade is somewhere in between here, because anytime it's closer to 2, who's that going to benefit? Yeah, right. So it's a zero-sum game, right? When one person benefits, someone else is going to lose. So there's no optimal kind of value that we would choose here. So I said at the beginning, this is just one hypothetical value to prove to you that trade is better off. You could go through the same thought experiment, choose 2.5, reproduce the numbers, and you could do a similar thing, right? So I'm not likely going to ask you to like prove that trade is making them better off. I'm just trying to give you some support, so I'm not just saying something and you have to just believe me, right? And I'm proving it to you that if there's any value, and I'm not going to sit here and do it for every single value in this range, but I'm going to choose one of those values and then kind of work that out for you. Does that make sense? Yeah. Any other questions here? Okay. So I've got this in the slides. It's basically, we're kind of working through everything that we did here. And all these numbers should line up with it. But I also wanted to think about, here we go. We'll do this. Last class, we said we had to walk before we can run. We kind of started out looking at individual production possibilities curves where they kind of were these nice lines, right? If instead we're interested in the economy-wide production possibility curve, so we're not just looking at 2 countries, we're looking at every country in the world. Or we're not just looking at 2 individuals, we're looking at, every individual in the economy, right? So if we're using a simplified model here with just 2 countries. We know there's more than 2, but if we can understand what's going on with 2, we can understand what's going on with 50 or hundreds. So if we have both countries only producing aircraft parts, how many total in the world would we have here? Yeah, 30 plus 10 would be 40. If they're both only producing iPhones, how many iPhones would we have in the world, or the entire worldwide economy? Yeah, 60 plus 50 is 110, right? So all we're doing is adding up how much each country could produce using all of its resources to find these 2 extreme points. Now, the next thing we'll do is we'll find this point in the middle. Initially, who do we want to rely on to first start producing this x-axis good, or aircraft parts? Whoever can produce it at a lower cost, or whoever has a comparative advantage. So who's that going to be? The US, right? So the US starts producing these aircraft parts, but they get to a certain point where they've used all their resources. So what should the slope of our worldwide production possibilities curve be here for these first 30 units? Well, who's producing them? So the slope would be -2. Right? The cost was 2. Our slope is always downward sloping, so negative. Now, if I want more than 30 aircraft parts, who am I going to have to start relying on? India, in which case my cost of producing any aircraft part between 30 and 40 is going to be -5. Right? So this would be, it's not a complete linear curve. It has some curvature to it. And notice, as I produce more of this good, what's happening to the cost of that good? It becomes, well, if it's a steeper slope, that means the cost is higher, right? And that makes sense. I'm going to have to start relying on countries who can produce this good less and less efficiently or at higher and higher costs, okay? So our economy-wide production possibilities curve is going to look something like this. This is just a simple 2-version model. If I was doing this with like every single country, what is that going to look like? Right? I just have more kind of segments on that production possibilities curve, and I get kind of this nice curvature to my economy-wide production possibilities curve. A what? Probably getting more closer to a macro concept. Yeah, we're looking at like economy-wide, worldwide things. Yep. Okay. So same kind of idea here. What's happening if I'm looking at this production possibilities curve? As I go to whatever the X good is, higher and higher quantities, my slope is getting steeper or my costs are getting higher. Okay. So here we'll go back to the slides and then we'll revisit this. So if we have kind of this economy-wide or worldwide production possibilities curve, it's not going to be this nice line. We're now going to have some curvature to it, right? And so you can think about if the slope is getting steeper, that means the cost is going up. So as I produce more of something, the fact that the cost is going up, we call that the law of increasing marginal cost. We kind of already talked about that last week, right? It's the same concept. If I do more of something or I want to produce more of something, I'm using less and less efficient resources. It's going to become more and more costly of what I have to give up in order to produce more of it. So we've got kind of this increasing marginal cost. You know, I always kind of give the example of like if I was part of this worldwide economy and we're talking about writing economics papers versus writing songs, if I took my entire life to write a song, I would produce like zero, you know, I don't even know if I could produce one song. The same amount of time I could produce a lot of economic papers. If we get to the point in the economy where we have to rely on me to write music, you know, we're going to be doing it at a significantly high cost, right? So as we want to produce more and more of something, we start to have to rely on countries, or even if we get it with just one country, we have to start relying on individuals who aren't very good at doing it, or they're good at doing other things, and so it's going to become more and more costly, okay? And we talked about this last class, but just to revisit it, put it all kind of into one graph, right? We talked about 3 zones, right? So if I asked you, remember we had 3 different things. We said, if I'm on my production possibilities curve, which is no longer this nice linear curve, but it now actually has some curve to it. Any point on that curve we said was what? Production efficient. So we're going to make a differentiation here in a second. So any point on the curve, all of those blue points, B and C are 2 of them, but all of them would be production efficient. Any point under the curve, we said we must not be using all of our resources, so it is production inefficient. And any point past that curve, I already kind of mentioned earlier, we said it was unattainable, right? So that's why I kind of jumped the gun last class. I think it made more sense in the context of what we were talking about. But just to kind of have a check of that idea, I wanted to make sure we revisited that. So what we can think about is we have these production efficient points, okay? So if I have any 2 goods, okay? Here's my production possibilities curve. What's going to happen if I wanted to then think about what is the cost, right? Or I could even think about what's the marginal cost of each additional unit here. Well, what tells me the cost of good X? From my production possibilities curve, the cost of good X is my slope. So notice initially, I've got my pretty flat slope. So for that very first unit, I'd come down here, pretty low cost. Now, as I produce that second unit, what's happening to my slope? Becoming steeper, or my marginal cost is higher. That's going to be true as I keep looking at higher and higher quantities of good X. So what do we have? Our production possibilities curve is really telling us that we've got increasing marginal costs. Okay? Now, this is the first part of identifying what's something we were thinking about last class. If I have marginal costs, if I want to know the optimal amount of good X to produce, what else would I need? My marginal benefits. All right, so we'll eventually see where these come from. But for now, if I just someone told you what they were, like I said, we'll tie everything in together at the end of class. But if I had my idea of what the marginal benefit to my society of these different units of good X was, they should be decreasing, right? Whatever the good is, the very first few units we have, it's going to be very, the highest value for society. As we have more and more of it, even if you think about something like defense, tanks, nuclear weapons, the first nuclear weapon is very, very beneficial to my economy, right? I now, have the threat, but going from 1,000 to 1,001, am I any more of a threat to other countries? Not really, right? So anything we're thinking about, we're producing more and more of it, that marginal benefit should be declining. We can then find where marginal benefit is equal to marginal cost. We're going to call this our allocative efficient point. So even though every point on our production possibilities curve, every point here is production efficient, we can map this quantity out. There's only going to be one point that's allocative efficient. Okay? One combination of good X and Y that we would say is optimal for society or allocative efficient. It's going to maximize the total difference between marginal benefits and marginal costs. Notice for every unit here, the marginal benefit is greater than the marginal costs up to that very last, that optimal kind of quantity. Excuse me. Any questions on this idea? So what we'll notice is every allocative efficient point will be a point on our curve, so it will be production efficient, but not every production efficient point is going to be the allocative efficient point. Okay. All right. So kind of talked about this already. We kind of just drew this out, but just in words. How do we determine what combination of good X and Y is optimal? Well, we said the production possibility curve tells us about the marginal cost. We don't completely understand where it comes from yet, but we at least have the concept of the idea that as we have more of a good, that marginal benefit will be declining. So what the specific values are, we'll touch on a little bit here when we talk about capital goods in a second. But we know that they're going to be declining. So we know that there will be some point where the marginal benefit falls below the marginal cost, and it will be no longer optimal for our society to kind of produce past that point where they're the last point where they're equal to each other. Okay. Any questions on this idea before we keep moving? Yeah. Why would I not produce? Where? Well, I'm always going to choose. So why am I not going to go here? Because this isn't total benefit. This is additional benefit. So if I produce the first unit, my total benefit would just be kind of whatever that marginal benefit was. What if the second, what's my total benefit? The marginal benefit from the first plus the marginal benefit from the second, right? So this is the key of marginal is the change in. It's not total. In fact, the way that we're getting to the highest total possible kind of net benefit here is by choosing where the marginal benefit is equal to the marginal cost. That will give me the point where my net benefits are maximized. Any other questions? We keep moving here. Okay. All right. We talked about allocated efficiency. The next thing we'll think about are changes in this production possibilities curve. So let's say I've got one of the following, right? If I have some technology change, or I have more people, or I have a change in productivity. All three of these things. So I'll do population first. If I just have more labor hours, so we started to kind of make this connection last class, and I had some people asking about, like, am I going to have to draw the graph out with hours? There's this inverse relationship. All you need to know, and I think it's fairly intuitive, is that if it takes me more hours to produce something, what is that doing to the quantity I can produce? If it takes me more hours to produce it, well, I have the same number of hours in a day, so I'm going to be able to produce less, right? There's an inverse relationship. If something all of a sudden, because of a technology change, I can produce it even quicker, now with the same amount of labor hours, I can produce more, right? So that connection between things that will reduce the amount of time that it takes to produce something, well, that will lead to the quantity actually being higher. So a technology change, right, is often we think about, it's making it so that workers can produce that same unit in less time, which means the quantity they can produce is going to be higher. Or if I just have more labor hours, right, I can make more of things, right? So anytime we had something that's going to impact goods, so if it's a change in technology that impacts all goods the same, or an increase in population, I've got more labor hours to just devote to the production of all different goods. These are going to be what we would think about as like parallel shifts, okay? So these are going to be parallel shifts where if I'm only, after I have more people or a population growth, if I'm only producing good Y, I can produce more of it. If I'm only producing good X, I can also produce more of it, okay? So these are going to be things that impact all goods the same, okay? So even if the marginal costs haven't changed, but we just have more labor hours or we have this advancement in technology, we're going to see kind of these shifts in our production possibilities curve. Now, I didn't draw it out here. It's because often we don't really, there just aren't as many examples, but you could see a downward shift, like a parallel downward shift. What might be something that would cause the production possibilities curve? It would affect the production of every good. So what's something that might wipe out significant parts of the population? War, right? Like something that would kind of, I mean, really, we have things happening at the same time, but there's a lot of countries experiencing a decrease in population. Like we're not replacing ourselves, the birth rate's less than 2. So that's going to cause maybe a downward shift in our production possibilities curve because we just have fewer labor hours, right? So when it comes to the exams, they're going to be what? 25 question multiple choice. So you can draw it however you want to draw it. That helps lead you to the correct answer, right? Now, generally, if I'm drawing an outward shift, I'll either use an arrow. If I'm giving you a graph, I'll go draw you an arrow, or I would kind of use notation 1 and 2. Like here's where we start out, here's where we're going. And we'll kind of have some examples of that in a second, okay? So what is maybe a little more interesting and will kind of lead us to thinking about this differences in allocated efficient points is what if I have a technology change that only impacts one good? So let's say I've got iPhones and wheat. I've got some technology advancement, but it's like, I don't know, the microchips used in iPhones has absolutely no impact on the harvesting of wheat, right? Well, if that's the case, what's going to change here? If I'm only producing wheat, can I produce more or less? The exact same amount. So I'm going to have no change there. If the technology change only impacts the y-axis good here, well, now with better technology, using the same amount of all of our resources, can I produce more or less iPhones than I was before? More, right? If I have the same amount of resources, but this technology makes them more efficient, it reduces the amount of time I can produce even more than I was before when I'm putting all of my resources towards the production of that good that had the technology change. Okay. Any questions on this idea before we keep moving? So we'll think about, and I've got this here, but I want to draw it out for us instead. And I'll just I'll say the question here. So let's say we had that quantity of wheat and we did iPhones, and I had here was the initial production possibilities curve. So if let's just say I somehow had information on what the marginal benefits were, I map out the marginal cost from that initial production possibilities curve. After this technology change, let me draw my axis a little bit higher. We said, well, hold on. I wanted to at first identify where is the allocative efficient point? It's where marginal cost is equal to the marginal benefit. After this technology change that only impacted iPhones, but not wheat at all, notice what's happening. If I were to look at the same quantity of wheat, what's happening to my slope? It's getting steeper. So the slope tells me the cost of my x-axis good. So what's happening at every single quantity? So if I were to look at this quantity, the marginal cost of that producing that amount of wheat is going to be, if it's steeper, that means the costs are higher, right? So at every quantity, because our production possibilities curve is steeper, the marginal costs are higher. That's going to be true at every quantity. So it's like we've seen this shift in our marginal cost curve, or our marginal costs have increased. And intuitively that makes sense because wheat was the good that didn't experience the technology change. If we want to produce more wheat relative to before, we now are giving up even more iPhones because there's now better technology using the same amount of labor hours. We could actually be producing even more iPhones than we were before. So these technology changes, if it increases, so here we've got the marginal cost of wheat is increasing. Well, what's going to happen? That's represented by the slope. What did we say 1 over the slope represents? The cost of our y-axis good. So the marginal cost of iPhones, well, if it's 1 over this marginal cost of wheat, if our denominator is getting larger, what's happening to the marginal cost for iPhones? It's decreasing. So this should make sense. Where does that allocated efficient point move? It moves down here, which would be a lower amount of wheat, but then a higher amount of iPhones, right? So that allocated efficient point is always going to shift towards whatever good had the technology change, okay? We'll work through it together here in a little bit. We'll have another example using the in-class quiz where I'll kind of think about what if it was the x-axis good that was changing. But we could do the same thing if we had the x-axis good experiencing technology change versus the y-axis good. I've got a question kind of for that in-class quiz later that we'll use. So we'll get an example of that. So I won't kind of do one right here, okay? Any questions on this idea? Okay. All right. So hopefully we're starting to see, I mean, we're using concepts from last week. We're talking about coming up with these marginal costs. This is going to help us out even next week when we talk about shifts in supply and demand. But we're now going to transition a little bit into thinking about this choice that we're going to make, and we can treat this like any other two goods, right? But we're now going to start thinking about countries have the choice of not just like wheat and iPhones, but the investment in the different types of goods, right? So here we're going to think about, we want to invest into capital goods that are going to lead to technology advances. So capital products are like investments, right? They're going to pay off down the road. So I might want to put money, you can even think about a good form of capital is human capital, right? I want to invest money into my country's education system. That's not going to have immediate payoffs, but that has payoffs over the next 10, 20, 30 years, right? So these capital investments are things that don't have immediate payoffs, but they have payoffs down the road. So even if we have two categories of goods, consumption versus capital, consumption goods would be things that like, I'm producing them today, the value is experienced today. This is, you know, we produce X number of automobiles today, they're purchased and enjoyed today. Or food, agricultural products are a good way to think about this. So I could do the same thing and think about, I've got the quantity of capital goods and I've got the quantity of consumption goods, right? I could draw a production possibilities curve out for the choice between those two. As I start to take money and invest it into these capital goods, I'm giving up some of what people can buy and consume today. Now, initially, what are they going to be giving up the things that they value the least, so the cost is relatively low. But as I start taking more and more of my money, investing into more and more of these capital projects, well, now I start taking away from people like, maybe I don't have enough food for my society. Maybe not enough people are finding housing, right? So there becomes a point where investing more and more into capital starts to become more and more costly, okay? So we can do the exact same thing as we did before and think about, for these different levels of capital investment, what is the cost? And the cost is in terms of the number of other goods these consumptions that give up. So I can almost think about, like, what's the marginal cost in terms of output that I'm losing? Well, we kind of talked about it earlier. That's just the slope of my production possibilities curve. We can see it's becoming steeper and steeper. So I've got the increasing marginal costs, right? Shouldn't look at anything really different than what we were doing before, okay? Now, this is where I need to know, if I want to talk about allocated efficient points, I need to know something about the marginal benefits, right? So before we can do that, let's think about, when I'm investing into these capital projects, it's coming at an initial cost. I'm not producing certain goods today. What I want to know is, this investment in capital, what types of increases in output is it going to lead to in the future, right? Because even though I'm sacrificing having more cars today, maybe I end up with even more cars over the next 10 years, right? By investing into these different projects. So we're going to start thinking about, and we won't put like an explicit function to it, but we're going to have some output function. So we're going to call this Q. This represents how much output of a specific good we can get from having a certain amount invested into capital, a certain amount of labor hours, a certain amount of like natural resources available, so iron, water, whatever we need in the production process. And then sometimes we'll see, if you like looked into this, and I think about it in the same way because it was the same, but you could even differentiate into capital like machinery and then human capital, right? They're both different types of capital investments. So there's some function that tells you, as I have more of these things, the combination I have of them, this is how much output I could get. So in general, if I have more labor, my output's going to go up or down. It's going to go up. If I have more capital, you think about this as like machinery, or even like the assembly line, like different production processes that might increase the output that my workers could produce. Generally, as these things go up, so would my output, right? So would this function. But my total output is not just going to be this function of the different combinations of these like inputs of production that we have, so capital, labor, things like that. It's going to then be multiplied, or this multiplier effect is going to come from the level of technology we have. So even if we have the same number of workers, if we have better technology, they can produce more, right? So we think about like something like AI and these generative tools, the same number of labor hours, if they have these tools that they can utilize, they can actually get through even more orders than they were before, right? Or they can actually, you can use AI to come up with like all kinds of things, right? And so they can produce even more than they were before. So there's this multiplier effect coming from A, what our level of technology was, okay? So we're then going to transition to thinking a little bit differently about this. We're going to have not the decision between capital and consumption goods. That was telling like our loss today, our costs today of investing in the capital. We also want to think about, okay, my investment into capital today, what's the change in the output that I'm going to be getting from that investment? So we're going to think about the cost is like loss of current goods, but the benefit is the gain of future output. So when I invest here, we're going to kind of make a slight differentiation between, if I invest $1 million, well, I want to treat that differently if I only had 100 workers as opposed to if I had 100 million workers, right? Like that same investment would be less. So we want to look at the per worker production function, or this kind of macroeconomic production possibilities curve, where we're looking at the relationship between capital invested per worker and output per worker. When I shorthand this, I'll typically write like capital and output, but it's always going to be on the per worker level. So you'll kind of notice that first $100 I invest, I'm going to invest it into what types of projects? The projects that are going to be the most beneficial or have the highest increase in my overall output. So initially, I went from 0 to 500. my marginal output would be 5, right? 500 was the increase. I had to spend $100 to get it, so 5. That's like our slope. For the next $100 I invest, I'm going from $100 to $200, but my output is going from 500 to 900, right? And then if I keep on going, right? What's happening to my marginal output from every additional $100 I invest? Well, every time I invest, I'm investing into the best project, then the next best, then the next best. So what's going to be happening to the marginal benefit or the marginal output? It should be decreasing. What tells me that from this graph? Anytime I invest in the capital, I'm going to get more output, but the output is increasing at a decreasing rate. Hopefully this sounds somewhat familiar from math classes that you should have taken in high school. So the slope of this per worker production function, or this macroeconomic production possibilities curve, this is going to be telling us about the marginal benefit of that investment into capital. So we can think about, we've got the marginal costs of capital, kind of what we're losing today by investing into it. And we just talked about, and I could put quantity of capital here, and we're thinking about the output that we're going to gain from that capital investment. We just said it's increasing, but at a decreasing rate. So if we wanted to then think about at these different levels of capital investment, initially, what's true about the marginal output or the marginal benefit to the country of investing into capital? It's relatively high. But then if they invest out here, now my slope is a little bit flatter. So the marginal output is going to be a little bit lower. I would then kind of map out that slope, and I would find that this marginal output, or what is the marginal output to the country, this is really going to be their marginal benefit, is diminishing, right? So we have this law of increasing marginal cost, which shows up in the production possibilities curve when we're making the choice between current investment in the capital and consumption goods. And then we also see the law of diminishing returns or declining marginal benefits between this relationship of current capital investments and the amount of additional output we'll get in the future. Yeah. Well, we can think about in this example, what is the marginal benefit to the country? It's the additional output they're getting from this capital. So the marginal benefit, usually we put it in like dollar terms, but when these production possibilities curves, everything we have is always in terms of the units of other goods. And so eventually, like after this week, primarily when we start to think about marginal benefits, it's always going to be dollars, right? Now you could think about if we have output, we could somehow come up with a dollar valuation to it by looking to see like kind of what prices are of the different goods. But for now, you can think about, yes, for the countries, this marginal output is just their marginal benefit, right? So it's the additional benefit they're getting, the additional output they're getting from these capital investments, okay? Nope. So what's true about the marginal costs? We said earlier, as I take more money and put them into these capital investments, what am I losing out on today? Consumption goods. And I'm going to lose out on more and more beneficial consumption goods to my economy. So what's happening to my marginal cost as I invest more into capital? So what do I want to do? I now have my marginal costs. I now have my marginal benefits. I want to put these on the same graph, right? I've got output into the marginal cost in terms of output. I've now got, I didn't write it up here, but right, we were graphing it out. So this was my marginal output, right? It was just in terms of this represents benefits. Here's my cost. I put them on the same graph, and what can I get? My equilibrium, or what up to this point we've only called it my allocated efficient point, right? So we could think about, given what we're just looking at, so we've got marginal output here. We're just going to put that declining marginal output, or you can think of it as the marginal benefit to the country. And then we're going to just put on the same graph, because we have the same y-axis, we have the same x-axis. We're going to write our marginal cost, which was in terms of output, and we can now identify our allocated efficient point. Now, what's interesting to think about, and I'm jumping the gun a little bit here, We're just working ahead of the slides, but I'll show you where it's at in the slides. So we had this per worker production function, which that's where the marginal benefits were coming from, right? So just like technology changes can impact our production possibility curve, when we're looking at maybe a technology change impacts wheat differently than iPhones or whatever the two goods we're looking at. If I have a technology change here, remember, what did we start out talking about before I looked at this per worker production function? The quantity we can produce from different types of investments in the capital led to different types of output, right? So what was a multiplier we had in this equation? A was technology. So really, our per worker production function was graphing out this function, but it had a multiplier in front of it. So if I see a technology advancement, given the exact same amounts of investment in the capital, how much output am I going to get, more or less? I'm investing the same amount in the capital, but now A is higher. I have a better technology available to my workers. Given the same amount of investment in the capital, I'm going to get more or less output. More at every single possible level of investment in the capital. So what does that look like? At every single point, what's going to happen to my output? It's going to be higher. So now I have this per worker production function that, right, if I don't put any money into capital, I don't get any output, right? I don't give my workers any machinery to work with. I don't even give them a pencil to write with. Like, I can't get anything, right? So what's going to happen? Not only am I going to get more output, notice at the same amount of investment in the capital, what's happening to my slope? It's becoming steeper, right? If I chose any 2 points and I go, it's getting steeper. So what did the slope here tell me? It was my marginal output or my marginal benefit. If it's getting steeper, that means that every output or every capital investment level, my marginal benefit is higher, right? So steeper when I'm talking about cost is a bad thing. When I'm talking about the benefits, the additional output I'm going to get, it's a good thing. My marginal benefits are higher. So what's going to happen if we see, and I say marginal benefits here, we could also remember this is in terms of kind of output. So if my marginal benefits are even higher than they were before, I was kind of using 1 to notate where they started out. What's going to happen to my allocated efficient point? Well, if there's a new technology change that makes investment in the capital even more, produce even more output in the future, I'm going to want to invest more in the capital. Sure enough, the allocated efficient point moves upward. Okay. Hopefully, we're starting to see all these things tie into each other, right? Any questions on this before we kind of transition? So in fact, they're the exact opposite, right? When we choose to invest more in the capital, the additional benefit we're investing into less and less efficient, so it's going down. The opportunity cost of investing in the capital, well, if I'm taking money and labor hours or whatever it is and putting it into capital products or capital projects, I have to start giving up things that I value more and more. So my opportunity costs are actually going up. Yep. Which is kind of what we have on here. Yep. Any other questions before we keep moving here on this idea? Okay. So I kind of already went through this. We talked about we've got this diminishing returns. I drew out this optimal level of capital for you. I then jumped ahead and said, what if we have a technology change? Well, it's going to increase that per worker production function. But what we said was if we looked at any same amount of investment in the capital, what's happening to my slope? It has to be getting steeper or, kind of representing the marginal output I'm getting is going up, right? Every single level, the same amount invested in the capital is becoming even more productive. So at this point, where are we at in time? Before we do this, let's do the in-class quiz today. Forgot the new quizzes. Should be more than enough time for us. All right. So it should publish here in just a second on Canvas's homepage. I am usually, if I can get to the homepage. There we go. So it should pop up under that homepage. So I'm generally pretty nice on these. So we're going to walk through these again today with each other. So, this won't always be the case week to week, but kind of starting out, I want to kind of reward those of you who are showing up. So, and I know that the material is still, a little bit daunting. We're still kind of getting to the mindset of thinking about things economically. So if I were to hit build and then go to preview. All right. So this first question, we've got two goods, nuclear and coal power. If I put nuclear power on the x-axis and I have a technology advancement that only impacts nuclear power but not coal power, what is going to happen to that production possibilities curve? Hopefully, this would not be too tough of a question based off of what we went through. I'm not even talking about allocated efficient points or anything here yet. So all we're thinking about is I had nuclear power and coal power. I don't know why that's so hard for me to say. If I have a technology advancement that only impacts nuclear power, what's going to happen? If I'm only kind of producing nuclear power, I'm going to get more. Only coal power, well, that wasn't impacted by this technology. So what's going to happen? I'm going to have not a parallel shift, but kind of this kick out of my production possibilities curve. So what's happening at every quantity of nuclear power? What's happening to the slope of this curve? It's becoming flatter, right? I mean, if I'm, like I said, put your pencil or whatever here, if you were mapping out at that same quantity, what's happening to my slope? It's getting flatter, right? And so what must that mean? When I have a good, like nuclear power, it's experiencing the technology change. If I have a flatter production possibilities curve, that means the cost to this x-axis good is going a flatter curve. That means I'm getting a slope closer to 0, which means my costs are going, right? So just like the example we had earlier when it was the y-axis good impacted, whatever good experiences the technology change, the cost of that good, it's going down. So here, the cost of my x-axis good is going down. Now, inherently, if I want the cost of my y-axis good, so coal power here, that's going to be 1 over the cost of my x-axis good. So if nuclear power, the cost is going down, if my denominator is smaller, what's happening to my fraction? If you divide by a smaller number, the fraction actually goes. So the good that doesn't experience the technology change, the cost of that good actually increases. Okay. Any questions on this? I'm hearing a lot of murmurings. We got anything clear on that? Okay. So the second question is talking about a technology change once again, but we're now thinking about our per worker production function or that relationship between capital and output per worker. So if I think about a technology change, we actually just worked through something that looked like this, right? We said, if I'm looking at capital kind of per worker and output per worker, we had this function that was increasing at a decreasing rate. Okay. So if instead I'm thinking about the allocated efficient point, we don't know, what the exact values are, but there's going to be some marginal benefits that we could calculate from this curve, and there's going to be some increasing marginal costs, right? So our allocated efficient point would be wherever the last unit where the marginal benefit is greater than or equal to the marginal cost. If we had a technology change at the same level of capital investment, we said, what's going to happen to the output that I get? It's going to be, so in general, if you have better technology, are you going to have more or less of something? More, so it's going to be higher or increase, right? Now, even though output is increasing, we also might be interested, well, what's happening to the additional output? Or what's happening to my marginal benefit or my marginal output? And how is that going to impact my allocated efficient point, right? And what do I have here? That's done. Oh, that's not what the question asks. But we can go through this and then I'll get to the question. So we got the first part of the question, which ultimately, what is that going to do? It's going to increase my marginal benefits, which we said leads us to this higher allocated efficient point. So we got the first part of the question. The second part is the country or firm that is experiencing the technology improvement will be more or less likely to have a comparative advantage in the goods that experiencing that technology improvement. Okay, well, now we're switching gears. So now we're no longer thinking about the production, the worker production function. We're thinking about the actual production of the goods. So we know that the per worker production function will see an increase, right? But if we're thinking about the types of goods that are experiencing these technology changes, we said anytime I have the good that experience the technology change, this was kind of from the first question, we said the costs of that good are going to be going down. If I have a technology change that makes me more effective at producing this good, the cost of producing that good is going to be lower. So if my costs are lower, the good experience in that technology change, costs are lower, that means I'm more or less likely to have a comparative advantage. I have a comparative advantage when my cost is the lowest, so I'm more likely to have that comparative advantage. So we had what? It becomes flatter and then increase and more. Okay. So have this open for the next couple minutes. Make sure you hit submit, right, on that quiz. I think I set it to be 12:11, but that should kind of cover it for those two questions. Okay. Any questions there? I know I kind of worked through these together. Once again, these are good things to go back and review as we get thinking about the weekly quizzes, but also towards the exams is a good set of things to look at. All right, so back to the slides. Right, we kind of took a break there. So one thing that you will likely see, and I say likely, I wrote the quiz, and this is on the practice problems. So you might want to know how to use this equation, okay? So I'm going to make some points on this slide that aren't completely clear, but it will be clear if you kind of go to the CL sessions, they'll talk through it, which is this idea of growth rates, right? So we're talking about investment in these capital projects. They're going to have a certain payoff, right? So what is the total payoff going to be? Well, basically, you could predict GDPs, and you could do a very similar thing, predicting what's the gain to a certain amount invested in a certain capital product. So if I take my original GDP, or you could think about this is my original investment into capital. Right? If I want to know what my payoff is going to be, or what my new GDP will be in the future, I would multiply that by 1 plus the growth rate. Now, the growth rate that I'm going to use in this equation is in decimal form. So 2% would be what? 0.02. And if I had 10%, that would be 0.1. So here in our growth rate formula, the growth rate is in terms of decimal form, right? It's not, if you have a percent, you can convert it just by dividing by 100, right? 5% is 0.05, 25% would be 0.25. You will then take 1 plus the growth rate to whatever number of years you're trying to make the prediction for. So if I say, okay, what will this GDP at the current growth rate be in 25 years? I plug 25 in here. If I want to know how much will this capital investment pay off in the next 10 years, I'll put in the number of years will be 10. Right? So it's really just a matter of being able to plug values into this equation. Okay? Now, notice there's parentheses here. So like 1 plus the growth rate, this should be 1.02 to the power of the number of years. Right? So it might be good to practice, look at that practice problem, kind of thinking about could you reproduce some of these values. And I'll even give you an Excel file where you could kind of work it out by hand here in a second that we'll look at. So now there's a general rule of thumb, which is just kind of interesting, and we can kind of prove this to ourselves looking at some actual data, which is that if you take the percentage of the growth rate, so this is where we won't use the decimal form. So let's say the growth rate is 7%. a general rule of thumb is whatever that growth rate is, you take 70 divided by it. That's how long it'll take for your capital investment or any investment to double. So if the growth rate is 7%, 70 over 7, your investment will double in about 10 years, right? If you had a 10% growth rate, then it would double in every 7 years, etc. Okay. So I've got this Excel example that we'll take a look at. So do not underestimate the power of compound interest. We'll kind of think about how this applies when we look at the actual values. So I opened up this Excel file, which was on Canvas under the week 2 module materials. And I just chose, let's say we invested $1 into capital, or our initial GDP was $1, just to kind of start out with a nice, easy value to think about it, okay? If my growth rate is 2%, and I put interest rates here, you can think of this as growth or interest rates. We could use the same thing to think about investments in the capital or even loans, if I can spell, right? So if it was 2%, how long should it take for me to double my money? I said I would take 70 and divide it by the percentage of the growth rate. So 70 over 2 would be 35 years. Sure enough, after 35 years, it would be $2, right? Go from or about, roughly. It's a rule of thumb. It's not exact. So it goes from $1 to $2. Now, I have this all like in Excel. I'm using cell references. But these are just values. You could reproduce this by taking the original amount invested. That was like our old GDP. You multiply that by 1 plus whatever the growth rate you're interested in is. And then I'm raising that to the power of the number of years. I've just done some tricky stuff in Excel with the cell references. If you aren't really that familiar with it, I'm not going to make you guys use Excel so that I could type this in one time and literally copy. In fact, right? If we get tricky with it, oops, I didn't mean to move that. If I use cell references correctly, you should all be like Excel wizards by the time you leave Kelly. I can reproduce that all very, very quickly. I only type it in one cell, right? So if you're interested in that, this is not the course where we will learn stuff like that, but there are several courses where you could, okay? What's else also, we think about if I had 10% growth rate, how long should it take for me to double my money? 70 over 10 would be 7 years. Sure enough, it's close, right? It's kind of getting close to there. It's just a general rule of thumb. So this hopefully helps show like, even at moderate like growth rates, like 6% is not crazy. In fact, if you were to go out and look, I was looking at this thing my wife was looking at. It's called ECON. It like rounds up if you spend and puts it in a thing. And they're like offering like 8% as their like kind of reported amount they usually get. So even like that's like low risk. I mean, 8%, I'm doubling my money in 9 years, right? And that doesn't sound like a lot if I'm investing $1. If I invest $5,000, I'm gonna have 10,000. That's a pretty sizable increase. So even moderate growth rates, not only does it compound pretty quickly, but countries aren't making decisions for the next 4 or 5 years. They're making decisions out 30, I mean, hopefully hundreds of years, right? So I'm thinking about even 2% over 35 years, I can double my money, right? And, like that's to say if I, could be a pretty, if my amount invested is moderate, like I could get a pretty good amount of return. Like if I'm putting money into a retirement account, I could, if I had like an inheritance and I threw that into a mutual fund, well, mutual funds don't often offer 2%. In fact, I put up a file on Canvas that kind of shows over the long haul on average, even though there's dips, if you were to buy a mutual fund that was tied to the S&P 500, there's no 10-year time frame where the average kind of rate of return is below that mean of 10%. So you can almost on average, as long as you can keep your money in a mutual fund tied to the S&P 500, you can expect to see about a 10% return. So if we look back here at a 10% return, I mean, I'm doubling my money in 7 years, right? That's pretty quick. And then if I think about if I could keep it in there for 20 years, I've almost multiplied my amount invested by 7, right? So we're talking about like retirement accounts, things like that. That's essentially what would be like your growth rate. Now we put it in like I started out in the slides, it was a more economy-based example, thinking about the GDP and how much GDP will grow. But it's the exact same concept if I put an amount of investment into a project or into a financial tool, some mutual fund or something like that. It's the exact same concept. Right? Now, unfortunately, It's also the exact same concept. If instead of the amount invested, this is the amount I'm taking out for a loan, and then this is my interest rate, right? I'll pay twice as much over the long haul if I have these different combinations of loans and number of years I'm taking to pay it off, okay? So I don't know, something you can kind of play around with a little bit. I don't know, I try to sprinkle some things in here that might be outside the scope of what I expect of you in this class, but trying to kind of connect it to with some of the material that we're going to talk about. I'm also going to, before we get out of here today, so we got 10 minutes left. I'll try to make this quick. So I've got this Canvas discussion kind of set to be released as soon as we're done with class. So I mentioned these week one. This will be set to have a due date of next Friday. So the end of the day, next Friday. A little bit more than a week to work on it. So obviously the module reading, the quiz for this week will likely take your priority until we meet again next Tuesday. But I've given you kind of a couple articles. Now this MIT article is very lengthy. I'm not expecting you like read every single line of it, but these two are like a little bit more friendly. Like this is like a review of that MIT article, so it kind of summarizes it. The second one I think was from, might be, yeah, MIT as well. So just kind of summarizing these findings that they found about ChatGPT and worker productivity. I posed some like questions and kind of, if you read this whole thing, you get an idea about how we can start to think about this new technology and how we can start to think about, well, what's that going to do to the change in the types of goods that we see countries or firms want to produce. Also thinking about things like, why could it be beneficial for consumers? What might it be doing to the cost? And then if the costs are doing a certain thing, what might happen to the price? So I, read this whole prompt. The questions, I'm not asking you to answer every single one. They're more of like questions to get you thinking about it. And then your response, right? It doesn't have to be necessarily like answering every single question, but it can be more of like even a comprehensive view of how you're thinking about how AI is tied to worker productivity, tied to the cost of different goods. What's that going to do? Is it going to be valuable for certain types of countries or certain types of firms? Whatever direction you decide to take it. Now, in your initial response, that'll be worth kind of 5 of your 10 points. You then need to respond, 5 of the 20. You then need to respond to 2 other students' responses. Each one of those will be worth 5. So that's a 15 out of 20. The other 5 in your initial response, right? And it won't allow you to respond to other students until you post your initial one. Right? So the way that these are going to be graded is my graduate assistants are going to go through these. And the bar is relatively low, I'll be honest. I'm looking for a thoughtful response. If it is a 1 sentence, that's not going to meet the criteria. It has to be a thoughtful response that at least touches on some of the topics or questions discussed here. In addition, they're always worth 20 points. So I've got 5, I said, for the initial post, 5 to each student. Part of your initial response, the other 5 points is going to come from using this data explorer. So I'm going to try to use these Canvas discussions, not so much just to be discussions, but have you show me evidence that you can do certain things outside of class. So this is simply going to be accessing a database, which I'm giving you the link to. And then I kind of walk through at the very end. I tell you what to click or what to select. I'll also have the class recording on YouTube, so you can always go back right now. But what I want you to do is go to this web page, go down here to the economy section, look at productivity. We're going to look at the base of productivity. We want to just look at current prices, right? And then we're comparing across countries. So instead of having everything in a country's own currency, we're just going to tie everything to, and it doesn't matter if you do per person or the converted. In general, like per person's probably, going to skew it a little bit. We have different populations, but we can do US kind of dollars. And then I want you to look at, if this loads for me, we're searching. Oh, there we go. This productivity database. Now, if you selected, I think, US dollars per person, it might give you a few more options. Oh, what is it? So this one. I think, oh, it's because I did it in a different order. So you might see more than just these categories if you selected a different type of US dollars. I don't care which one you select, as long as you select one. It's just putting all the denomination the same. But you do want to get to this productivity database tab. Once you go there, now we're going to click on table. Oh, or didn't it like? Oh, it's going to tell me. There it goes. If I click on the table, it can only give me the per hour one. There we go. So you'll want the per hour US dollars in order to be able to view it on a table. So all I want you to do in your initial response is based off of what you said, kind of what you think about the connection between ChatGPT and what countries might experience it, might be impacted differently. Just go out and mention one country, a group of countries, or just kind of a general trend. Look at, give one country and what its change in productivity has been over the last 5 years. Or just give me one country and tell me what its change in productivity has been in the last 2 years versus the 2000 to 2001, where you believe that ChatGPT might have been used more or less. So all this is a way for you to do is to show me you can go to this database, go out, get to this point of the data, and then just report to me a data that shows some support that productivity is increasing, or if it's decreasing. I don't think there's any country here, but maybe, I didn't look through it with a fine-tooth comb. There might be one country that's seen a decrease in, actually, I bet I know one. Where they don't, it's not on here. I was going to say, I bet the Ukraine has seen a decrease in productivity, right? So we have I'm not trying to be, I'm not trying to be trivializing that, but that's what we would expect, right? They're experiencing something that might have actually caused a decrease in productivity. And so just reporting some of the values for one country, what's happening to their productivity levels over time, as long as you're referencing that data, that gets you the other 5 points. This is just, like I said, trying to build some skills of going out, be able to look at some of these different databases, even if it's just, like I said, it's just clicking on things. It should be pretty easy, but at least shows me that you can go out and kind of get to that point and then actually view the data based off of watching what I just did in class or looking at kind of the instructions at the very end of that initial kind of Canvas discussion prompt. Okay. All right. So other than that, I think that should do it for me. So first CL sessions tonight and on Monday. Have a fun, safe weekend. I will see you guys on Tuesday. Sorry. Today is Thursday.
Thank you.
Yep.